Have you ever tried to find the end of a rainbow? I know I have, but I never found it. But hey, don't feel bad. Even Isaac Newton couldn't catch one, and he basically invented colors. Or did he? Today we're diving into the dazzling world of rainbows. Spoiler alert, they're not actually made of Skittles. I know I was disappointed too. But what we're about to uncover is way cooler than candy. We're talking light-bending, raindrop-reflecting, eye-tricking magic that happens right above our heads. And the best part? By the end of this video, you'll be the smartest person at any party when someone mentions rainbows. So, put on your physics goggles and let's chase some rainbows. These stunning natural phenomena have captivated humans for millennia, but do you know how they actually form? Let's break down the science behind these colorful arcs in the sky. First, let's talk about light. Sunlight may appear white, but it's actually composed of all the colors of the rainbow. When light travels from one medium to another, like from air to water, it bends. This bending is called refraction. Now, picture a raindrop. When sunlight enters a raindrop, it slows down and bends. The light then reflects off the back of the raindrop and exits, bending again as it leaves. This process separates the white light into its component colors, much like a prism. But why do we see distinct colors? That's because each color of light bends at a slightly different angle. Red light bends the least, while violet bends the most. This separation of colors is called dispersion. So, how does this create a rainbow? Well, it's not just one raindrop, it's millions of them. Each raindrop acts like a tiny prism, reflecting one particular color more strongly back to your eye depending on its position. The classic rainbow arc forms because of the specific angle between the sunlight, the raindrop, and your eye. This angle is always about 42 degrees for the primary rainbow. That's why you'll always see the rainbow in the same position relative to your line of sight. But wait, there's more. Have you ever noticed a second, fainter rainbow above the main one? This is called a secondary rainbow. It forms when light is reflected twice inside the raindrop before exiting. This double reflection inverts the order of colors, which is why the secondary rainbow appears with red on the bottom and violet on top. Now let's address a common question. Why don't we see rainbows all the time when it rains? The key is that the sun needs to be behind you, and the rain in front of you. The sun should be low in the sky, typically no more than 42 degrees above the horizon. This is why rainbows are most common in the early morning or late afternoon. Interestingly, no two people see exactly the same rainbow. The precise rainbow you see depends on the position of your eyes. Move, and the rainbow moves with you. Rainbows aren't limited to Earth either. They can form anywhere there are sunlight and water droplets. We've even observed rainbows on Mars. Before we wrap up, here's a cool fact. There are actually many types of rainbows beyond the classic arc. Fog bows, moon bows, and even circular rainbows can occur under the right conditions. And there you have it, folks. The next time you see a rainbow, you can impress your friends by shouting, "Look!" It's a naturally occurring spectral phenomenon featuring sunlight, airborne water droplets, and your eyeballs. They'll either think you're a genius or slowly back away. Win-win, if you ask me. Remember, rainbows are like science-y snowflakes. No two people see the exact same one. So technically, every rainbow you see is your rainbow. Feel free to name it. I call mine Steve. Now, if you'll excuse me, I'm off to patent my idea for rainbow-flavored water. It can't fail. Leave a comment telling us about your most memorable rainbow experience. Bonus points if it involves a leprechaun or a unicorn. Until next time, keep your head in the clouds, your eyes on the sky, and maybe bring an umbrella. You never know when science might strike.